Yeah. And we are recording this
We are
time.
recording. Okay, guys, if you don't want the world to hear, don't say it. Before we start, I've been meaning to do this. How do we do this, Melanie? I brought two books in that I think are wonderful, and that if you can find them online used, they're not that expensive.
Yep.
So what do I do with this?
Oh, yep.
You want to do it?
This is The Grand Tour, A Traveler's Guide to the Solar System by Ron Miller and William K. Hartman.
And you guys can always call me at home if you want details. But this is basically a combination, an astronomer and an artist. And oh, let me see here. You got this up on the computer, that one picture that
Oh, yep.
we're going to switch to the computer for a minute.
Oh.
There we go. Wow, that's not bad. Whoops, where'd it go?
I gotta share my screen. I'm gonna share this picture with you.
All right, why I love this book. It was based on one of those Voyager tours. No men involved, just machines off into space, going through our solar system 20, 30 years ago, taking pictures of things we had never seen. Then the artist got involved. And you know how sometimes artists can make it more real than real. And why I think this book is so important. Most of us grow up in one place and we assume that everything around us, whether what our parents teach us or what the world looks like, what our neighbors look like, is what the whole world is.
Mm-hmm.
And in astronomy, if we could put ourselves out there somewhere in the solar system and stand on another planet or another moon and look around, I just think it's the most amazing, expanding your brain possibilities. Yeah. So this is an artist's rendition, but based on science, of if you were standing on one of the rocky mountainous parts of the moon, looking towards the horizon, what do you see there, guys, with the black sky and the stars behind it?
The Earth rising.
Yes. Now, something, we won't go into it this time. Maybe if this program goes on for a year and we recycle some of the material, we can go deeper. So we're not going to go deeper into why this is true, but I'll just tell you, and I never realized this until very recently. If you lived on the moon, the night would be 14 days long, and the day would be 14 days long.
Okay.
But the Earth would always hover just as you see it on the horizon, pretty much on that same spot.
Oh.
And I do know why that is true, but we're not going to go into it today or we'd never get out of here. Okay, so that's one gorgeous.
Okay, can you repeat the name of that book, please?
Yes, The Grand Tour. That's all you really need to know.
And by Miller and who?
Hartman, Hartmann. All right, the second one, which I've mentioned before for beginning astronomers, is 365 Starry Nights.
Oh.
And there's a page or two for every night in the year.
Yeah.
They start, I think, in December. Yeah. And in very layman terms, they explain, the zenith, how things, et cetera, et cetera. They throw in a little bit of the astrology and the ancient myths. And they have, here's one for June 21st. Whoops, is that, can I see? And that's you standing on the Earth, and it just shows you what's happening with the sun, et cetera, et cetera.
Let me stop sharing my screen.
But it doesn't matter. Take it. Like that.
Yep.
So anyway, that's for someone really interested in a simple but elegant. Here's another one for March. Remember, Debbie, we talked about the beehive open cluster. So it just shows all the stars at that particular time of the year and the constellations, et cetera, et cetera.
Mary Lou, who's the author on that one?
Okay. I'll just give the last name, Raymo, Raymo. Chet, C-H-E-T. And it's been around for a while, but then again, in our lifetime, the stars don't change much. We just learn more and more and more about them. And then from my magazine, Astronomy Today, she took another picture of what's coming up in 2 days, guys. And I thought, gee, we should have arranged a field trip. But the problem is we'd have to go to Hudson Bay or the Arctic Ocean or Eastern Siberia. And I didn't think I could get anybody to do that.
No, thank you.
So Melanie is going to try, and I think she'll succeed in putting, this is happening in 2 days. And just like 2 or 3, whatever it was years ago, when we put on the computer from some astronomy place, the transit of Mercury across the sun. Well, that happened very slowly. I think, was it 8 hours? And all it was that little black dot moving across the face of the sun. This is going to happen in more like 4, 5, 6, 7 hours. I think it's going to cover 7,000, 8,000 miles on the surface of the Earth. So you can catch it on the computer if you can't manage to get up there to see it in person.
And this is an eclipse of the sun.
Yes, an annular eclipse of the sun.
Okay.
So ignoring my order of what we're going to talk about, Debbie, didn't you have the definition of that to look up, as I recall?
I had tidal bore
Yes, we'll get to that in a minute.
and I had Bailey's bead.
Oh, Bailey's bead. Well, we'll wait. Did anybody have an annular eclipse? There's a bunch of people missing today.
Yeah, no,
All right.
no, I thought our questions were all on the moon. Oh, we had eclipses. Oh,
Well, it's a
okay,
type
you
of.
mentioned that on June 10th, the solar eclipse.
Okay. In the middle here, you see this black circle with a little orange band around it. If that were a total eclipse, the whole sun would be blocked out.
Yeah.
You wouldn't see any rim. But sometimes, remember, the moon does not orbit in a circle. It orbits in an ellipse. So once in a while, it's closer to us than other times. Sometimes it's a little further away. If it's further away, it's smaller compared to what we can see. And therefore, it doesn't cover up the whole face of the sun. And you have what is known as an annular eclipse. And that's what's happening on Thursday up in the Arctic. Okay. All right. Let me find page 1 here. June 8th, tides and eclipses. So we've got a lot of material to cover. I went over the books. I need to do a little bit of review because so many people missed last time. And I think these are really, really interesting little tiny bits of information. So once again, depending on where you live on the Earth, when you look up at the sky, sometimes things look quite different. For us here, roughly what, 41, 42 degrees north, which means we're about halfway from the equator to the North Pole. Whenever we see the crescent moon, whether it's the new one in the evening twilight, or if you get up at 4 and 5 in the morning, it's a crescent moon almost disappearing again, but it's in the dawn sky. It's always, sitting there sideways. How can I say this? Can you put your hand there? Yeah, more or less. However, if you live down near the equator, you would never see it that way. It would always be a smile. In other words, it would be lying on its back.
Okay.
And if you were an Inuit way up in the North Pole, it'd be a frown
Oh,
hanging upside down. And that's all three-dimensional geometry. Living on a curved surface, looking up at a moon that orbits around, think of like the record player going around and around at a tilted angle. So everything shifts from day to day, from year to year, but we do have cycles that we come back to where we were once upon a time. So, okay, that was the crescent moon shape. I think somebody answered. Jordan, I want to hear from you guys. Are you there?
I'm here. Yeah.
Okay, anybody else there?
No, just me.
Just you. Oh, you're gonna get stuck with all the questions. Okay. I forget, I think it was Bob or somebody. I said that the moon is creeping away year by year, a little bit further from the earth. And I wanted to know how far that was. And Bob, I think it was, came up with about an inch a year. Now, an inch a year doesn't sound like very much, does it?
Not when you're talking about the
No, but
universe.
it's quite a
But
bit.
when you're talking about astronomical time,
Yeah.
it all adds up. And so Bob's not here today. I don't know. I didn't look it up. So if we don't have the answer now, maybe we can find it for next time. Eventually, as that moon moves away, it gets smaller for what we see, right?
Mhm.
Therefore, the time will come when there'll be no total solar eclipses because the sun won't be close enough, big enough to hide it. So we're going to find out when that is. I don't think it's going to be in our lifetime.
Right.
Okay, that was number 2. Number 3, I think I forgot to even mention this. Anybody know what a supermoon is? Because that's what happened with Jordan, who will talk about it briefly in a bit. The eclipse of the moon, it was a supermoon. What does that mean?
It's when the moon is closest to the earth and it's
Oh.
full.
Yes. Now, why is the moon, Mary Lou, sometimes closer to us than other times?
because of that elliptical
Yes, orbit.
Orbit.
Right. Remember, only the ancient philosophers thought everything was a perfect circle. And that turned out not to be true. So since it's an ellipse, there are times, just like the earth, when we are closer to the sun, when the moon is closer to us. And when that happens, the moon appears 7% larger and brighter. It's not a lot, but 7%.
And it looks bright. It looks largest on the horizon
Ah,
because of the
I'm getting to that.
illusion. Oh, yeah.
Okay, Jordan, did anybody in your crew go and stand upside down and look through their legs at the moon on the horizon?
I don't think so.
Yeah, I didn't think so either. You guys, we're gonna have to find a new crew to do these experiments. Well, here's another way to do it. That is a very famous illusion. And anybody that has ever seen a full moon rise and then later in the night look up at the same full moon
Right.
will swear to you up and
Yeah.
down, they'll bet $1 million the moon is bigger when it's rising on the horizon. But it isn't. It's an optical illusion, partly due to the atmosphere, right? But you can prove it and you don't have to go to the park and stand upside down. Early on, we talked about measuring things in the sky in degrees, using your hand at arm's length, held out. And your pinky is 1/2 a degree. And so is the full moon. In other words, if you held up your pinky while the full moon is rising on the horizon, it would cover the moon, in spite of what your eyes are telling you. And later that night, when the moon is straight overhead, 6 hours later, you hold up your hand, stick out your pinky, and it will still just cover the moon. So I think that's an experiment worth trying for everybody, not just the young folks, because you can't always believe what you see, especially in astronomy. Sometimes there are illusions, and many of them are understood now scientifically why it happens. But that's a real easy way, without embarrassing yourself, to check it out. Now, something I didn't know about until the last year or two, and that is the Saros, S-A-R-O-S, cycle that Bob was going to look up, and he's not here, so I'm going to just briefly mention it. I'm assuming it's named after somebody Saros, but I'm afraid I forgot who that was, and I forget when it was. Was it 100 years ago? 200 years ago? Don't know. Geez, maybe it went way back to Babylonia. Somebody ought to check that out. Who was Saros, and when did he live, and when did he discover this cycle? Now, a very simple way to understand this is we all know the sun shifts throughout the year. And once again, think about the sunrise. Only twice a year in March and September on the equinoxes does the sun rise due east. Then as summer progresses from March to June, each morning the sun will be a little bit, if you're facing east, to the left. It's moving north along the horizon for 23.5 degrees because that's the tilt of our axis. And then it starts swinging back. And that, by the way, is the summer solstice, back to September. And then into fall and winter, it goes to the south. Well, the moon does the same thing. It shifts along the horizon, both for rising and setting. And it takes 18.5, rounded off, years to swing the full cycle. From north to east to south, back to east, back to north, 18.5 years. And that's the Saros cycle. And they have two definitions. The northern stand still and the southern stand still. And because when you get close to those endpoints, it doesn't seem to shift much for a few days. It stands still at dawn or at sunset, if you're checking that on the horizon. And somebody, I read it and I forgot it. I didn't write it down. Someone might want to look up where we are in that cycle right now. And this was part of Brock's assignment to every month take a picture of the full moon where it was rising compared to the background, because it's moving. It's not going to rise in the same place. And Stonehenge, which we usually tend to think of as a monument connected to the sun, also had wooden posts that were connected to the moon. So maybe next year when we come back to maybe talking about the moon or cycles or whatever, we'll go into it more deeply. All righty. The moon affects the earth. I figured out, well, there's more than 3 ways, but the 3 most obvious things are tides, which we will get to today. But being a large moon wouldn't work if it was a tiny moon, but being such a large moon compared to us, it stabilizes the tilt of our axis. And if we didn't, it's possible that if there was no moon or no big moon, our axis would shift more than it does now, which is very little. And that would mean our seasons would get all screwed up. And I'm not sure we would enjoy that. And finally, see, the moon is basically responsible for slowing our rotation. And that's due to the friction of the ocean and the tides. And once again, we all assume, how long is a day, guys? Jordan, how long is a day?
24 hours.
Yeah, well, if you wanted to go back 4 billion years, it'd be 5 hours. We'd be whipping around. So we have slowed down and we'll continue to slow down.
So
So,
what is it? Wait a minute. What is a slow down?
okay, because of the moon creating the tides, and
Yeah.
the tides, the ocean creates friction. The earth is turning under the ocean, you could say. And so the spin of the earth from its original spin rate is slowing down from 5 hours, zip, 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 in a day to 24.
Okay.
Okay. 2 more things before we get on to tides. The apparent size of the sun and the moon. Now, y'all know you don't look at the sun. However, we have all, especially if there's a high haze or cirrus clouds, you can quickly glance up and you think, wow, the sun looks the same size as the moon
Yeah.
without getting out the calipers and or your
Mhm.
fingers and just in general, it's about the same size. Well, how could that be? The sun is so big. Well, it's one of those rare coincidences. I read a lot of mysteries, and somebody always says, I don't believe in coincidences. But every now and again, even in astronomy, which is usually math-based, and if you remember your geometry, there are no coincidences. You have this premise, and you have A and you have B, and what's the shortest distance between A and B? Well, it's got to be a straight line, according to the premises. Well, here's why they appear the same size. It just so happens the moon's diameter is 1/400th that of the sun. But it's 400 times closer. And once again, I didn't do the math. I trust the book that the math was right. In that particular case, they then look the same to us from the Earth's surface. So once in a while, once in a blue moon, coincidences do happen. All right, Jordan, you're up for your adventure at 4 a.m. What happened?
Wait, what?
Okay, what happened when you got up at 4 a.m. to capture with your own eyes the lunar eclipse out in San Diego?
Yeah, I got a kind of good look at it. It was kind of hazy that morning, but it was kind of yellowish, I guess.
Mhm.
Not the red that I've seen in other pictures, but it was pretty cool. I didn't see the valley thing that you mentioned though.
You didn't see the what?
I didn't see the valley thing that you mentioned about the
Oh.
light going through the valleys.
Oh, the Bailey's beads.
Yeah, that.
Okay.
I didn't see that.
No, that I think that's hard to see. And if you didn't have a really clear, no fog, you probably couldn't catch that. But Debbie's going to talk about that, I think. Right, Debbie? Didn't you look up Bailey's beads?
I did.
Oh, why don't you tell us what they are?
I thought that they are, they form around the outside of the sun. Instead of seeing a complete circle out there during an eclipse, you might see tiny little spots of light along the edge.
Mm-hmm.
Is that it?
Okay, I can elaborate. This usually occurs with a lunar eclipse. And think about it. The moon is not a perfect sphere like your beach ball. It has mountains. So sometimes, depending on where it is in relationship to us, if we had sharp enough eyes or a good telescope, you could actually see the mountains sticking up on the edge of the moon. Well, as anybody that's ever driven out west in the dawn, sometimes the sun will come up through the mountain valley, right? But if you're on the side of the mountain, it hasn't come up yet. So if you have a total lunar eclipse, just at the moment that totality is occurring, there'll be a few gaps along the perimeter, which is the sun still shining through the valleys that the mountains are blocking out. And it only lasts for like, I don't know, a few seconds. Is what I would guess. And I'm assuming again, it was a Mr. Bailey somewhere,
Yeah.
maybe in the 1800s. I'm not sure. Okay. Oh my, that's sort of catching up on what we all missed. All right, tides, finally.
Do you want me to bring up the picture?
Yeah, she's going to bring up the picture of the tides, but let's go through the questions we had. And I don't know if everybody's here. So how many high tides do we have in a day? Anybody?
2.
2, yes. And they don't occur the same time every day. If the second high tide is, let's say, at noontime, two of those later, in other words, roughly you'd think, well, 24 hours later, there's going to, but that's not true. What's the time difference there? which is why you need tide charts, time charts, if you go sailing or want to go out on the beach and not get caught out with the tide coming in when you don't think it's ready to come in. Does anybody remember that one? Okay, let's go back and see if anybody remembers day 1 on the moon. I mentioned that the full moon rose 50 minutes later the next night. Do y'all remember that? Because while it's spinning, it's also moving around. And so it's shifting on its orbit in relationship to us. So it's like 50 minutes to catch up. So that's the same thing with the tides. They tend to be 50 minutes later every day. So if you're swimming or sailing or live by the ocean, nowadays, I suppose you have an app on the phone. But in the old days, it used to be like a paper chart that would come out every month when the high tide was going to be in the daytime. Alrighty. Who found out where the highest tide in the world was?
I did, and that
Okay.
is in the Bay of Fundy, which is between the border of New Brunswick and Nova Scotia in Canada.
Yes, right. Okay. I was actually up there once and I was just trying to remember my geography. That's what I thought, but I wasn't sure. Mary Lou, I didn't ask you to, but how high is that tide? The difference between high and low?
It can be about 40 feet.
40 feet. Okay. So there are some places in the world where you hardly even notice the tide difference. Anybody want to guess as to what might affect, why is it so high in some places and just kind of mediocre in others?
Maybe your proximity to the equator or equator.
That's I think an educated guess, but it's not right. I don't believe,
okay.
but that's okay. Don't not try and guess something because you don't always get it right. It's mostly due to the contours of the land. The Bay of Fundy, the ocean, like New York City with hurricanes, there's a funneling effect. So wind and current, the bottom underneath the what the surface of the earth under the water there is, and all those things will affect how high or how low the high tide is. Alrighty, a tidal bore.
Oh,
I
that
think-
was me.
Okay, Debbie, I stuck you with a lot because I knew some people were not going to be here, and then you were on the phone to me, so I thought, okay, I'll just give them to Debbie.
That's okay. What I found was that when the tide is coming in, the forward or leading edge forms a wave that travels against the direction of the river, or it could be, I guess, a narrow bay or something, but if the tide is coming in, the leading edge will form a wave that travels up the river or up the narrow bay against the direction that the river or the bay is going. So it sort of bores right into it.
Okay, that's pretty good. Most rivers, what do we think? They start in the mountains, they come down, and they wind up going out to the sea. So you can imagine somebody who's an explorer finding this river and all of a sudden, hey, wait a minute, it's going backwards. What is going on here? Well, the force, some of those rivers, the force of the incoming tide is so powerful, it overwhelms the force of gravity, bringing the water down to the sea. And it actually does raise up a wave. And I remember when I was a kid, 36 miles above New York City, near Bear Mountain, the Hudson River, you could go crabbing illegally off the docks there at night, because the salty water from the Atlantic Ocean actually comes those 35, maybe 40 miles upriver. And so the crabs live in that more salty water. So a tidal bore. And what else? Oh, Jordan, back to you. It's been a while now. Maybe everybody has forgotten about that great big tanker that got stuck in the Suez Canal. I asked you a couple of weeks ago, how did the moon really get that boat unstuck?
It helped with the tide, so that when the tide, it made the tide rise, so that the ship was floating. For everything they dug out, the water could fill it in, and then it made it a lot easier for them to pull it around. And they got
Right.
the back out first, and then they got the front.
All right. And it was a spring tide, which is another phrase that I'm not sure we mentioned. That happens a spring tide happens almost once a month when the sun and the moon and the earth are all lined up. So they all work together. So say the Bay of Fundy's tide normally is exactly 40 feet, which of course it isn't, but say it is. Then on a spring tide once a month, it might be 41 feet. And I'm thinking in Egypt, that 1 foot made all the difference. So I kind of get a kick out of human beings scurrying around doing this, that, and the other thing. And Mother Nature is just there saying, well,
Wait a minute.
I think I'll take a hand here and help them out. Okay. Now I asked, this was more of a philosophical kind of a question. Everybody, a couple of weeks ago, imagine yourself sitting on a beach somewhere and you arrive at low tide. And you spread your blankets out a couple of feet back from the edge of the water where the sand is nice and damp and firm. And you sit there doing whatever, reading, eating, sleeping, listening to music, whatever you do. And 6 hours goes by and gradually the water is coming higher and higher, closer to your blanket. You finally have to move. And I asked you to think about what really is going on there with the earth, you, the water. Did anybody spend any time trying to figure that out?
Maybe I shouldn't have stopped sharing the screen.
Yeah, Melanie is trying to find the up in the right-hand corner, low tide, high tide. Okay, I'll admit, I never thought about this either. It's obvious the water is moving, right? But once again, in this case, the obvious isn't really what's happening. What's happening is this bulge, and in a minute, I'll go back to why there's a bulge on both sides. The water is permanently attracted to the moon. And as the moon moves, let's say counterclockwise, I think, that bulge of water, the ocean, is following the moon. So in a sense, the water is not really doing anything. It's the earth turning under the ocean, rotating, that is causing the tide to rise where you are sitting. And once again, that's like, really? Boy, I never thought of that. Who would have thought of that? And so, once again, if you're going to be somewhat of a scientist searching for the truth, you can't always accept what seems the truth, what seems so obvious, what seems, well, that's got to be what it is. It takes more than that sometimes to find out what is really going on. Now, for years and years and years and years, I could perfectly understand why there was a high tide on the moon side of the earth. And for the life of me, I could not figure out why is there a high tide on the other side.
Yeah.
Didn't make any
I was
sense at all.
surprised by that too. You
All
would
right.
think that there would be a low tide on the opposite side.
That's right. However, we're forgetting the laws of gravity. It affects everything that has mass. So the moon is not just attracting the water, but it's also pulling on the earth. And the closer you are, the more powerful the pull of
Yeah.
gravity. And so it pulls first on the water, then on the earth, and the earth is being pulled away from the ocean on the other side. It's still a bit of a head scratcher, but it makes sense if you really stop to think about the laws of gravity. So anyway, the mysteries of tides. Finally, okay, eclipses. I think we had a bunch of questions. Mary Lou, did you have the phases of the moon for solar and lunar eclipses?
No, I had where was the highest and the lowest tide.
Okay, you didn't have a question then on the, did anybody have that question about what phase does the moon have to be to have a solar or a lunar eclipse?
Oh, well, doesn't that have to be full?
For which one?
For both of them?
Nope.
Okay. For the solar eclipse, the moon is between the earth and the sun, so it has to be full.
No, when the moon is between the earth and the sun, we don't see it. And that's what phase?
New moon.
The new moon.
Okay, the new moon.
Okay, so, and then when we have a lunar eclipse like we just had,
Yeah,
in
and the
Georgia,
earth.
that was the full
the sun
moon.
is moon, right.
Yep. So, and once again, you can see here, the moon would be over here, would be full, right?
Mhm.
And over here, we wouldn't be seeing it. And that's when we get a solar eclipse like we're going to get in 2 days. All righty. We already went over what an annular eclipse was, and it's coming up in 2 days. Let me see what this is. Okay. Why don't we have an eclipse then every month, both solar and lunar?
Because the orbits aren't perfect circles.
What's the no, but it has to do with the
So
tilt.
that, yeah, they're not.
Okay, in other words, if this was flipped sideways 90 degrees, according to this diagram, the moon would, like a record, would be running around on the same
Mhm.
track, and then you would have one each month. But this circle, which is really an oval,
Mhm.
is tipped 5 degrees from our plane, and so that sometimes it's above 5
Mhm.
degrees, sometimes below 5 degrees. It has to be right smack on to give an eclipse.
Mhm.
So that's why they don't happen all the time. I think I mentioned this before, but everybody should write it down in their calendar because it's going to be a big day. In West Almond's going to be the edge. So all we have to do is drive to West Almond and we will see a total solar eclipse in the April of 2024, which is only 3 years away.
Mhm.
So that's going to be a big deal. We talked about Bailey's beads. Okay, here's something for you to think about between now and the next 2 days when we're going to have that annular eclipse up in the Arctic. If it were a total eclipse, totally blacked out the sun, what constellations would we see in the sky? If it were now, okay, we'll leave it for that. Up in the north there, what constellations would you see in the daytime? We'll leave that one just by. What's that?
I think the Big and the Small Dipper.
Okay, and some others. Yep. I was going to make it harder and say if there was a total. Okay, here's another question then. if it's clear and we get to see it on the 24th of 2024 in April, down here where we are, what constellations would we see? So you look that one up, figure out what they're there now in the daytime sky, but we tend not to think about them because we can't see them in the daytime.
You know it's gonna rain that day.
They're gonna rain. Oh, that's what I
It's gonna
forgot.
be cloudy.
You know what? It would not be worth us spending the money to go on a field trip up to the Arctic or Hudson Bay or Eastern Siberia because, well, maybe I'll show it. The magazine gives a weather report based on climate over many decades. Can you show the orangey one?
Oh, yeah.
The darker the orange, the more clouds.
Oh, am I-
Oops.
let's stop share.
And it's cloudy almost the whole time in those places, which is why nobody lives there.
Okay.
So it's going to be really good luck for any of those scientists who travel to
Mhm.
try and get it. So
Yeah.
anyway, alrighty. Before we move on to next time's questions, I did some calling around, and mainly it was Sandy who was going to host our star party. And when and you're going to laugh, she says, I can't come until the sour cherries are ripe to pick. She has a wonderful sour cherry tree in her yard in Albany. And every year we trade. I grow her a couple of butternut squash, and Ariella, her daughter, who's out of college now, climbs the tree and picks, because it's getting taller and taller, and picks me a couple of pints of cherries. So we got to wait for the sour cherries. But we decided probably June 26th, Saturday evening at 8 o'clock. It'll still be light, but we can gather on her porch and patio. She has a splendid view to the north. And what we're going to be doing is studying the circumpolar stars. All right. And it'll be dark enough by 9:15, 9:30. So take a nap or sleep
So-
late
So who
Saturday
is
morning.
this?
Pardon?
Where is it? Who
Okay.
is this and where is it?
Okay, it's out on Vandermark Road. Let me think. You know where Five Corners is, everybody?
Yes.
So you go towards Scioto, about
yes.
5 miles. We'll get better directions,
Okay,
between now and then.
okay. And whose house?
Sandy Rosner. She and Jeff live in Albany, but they have a summer place there on Vandermark Road.
Okay,
We'll get a map up.
okay.
All right. Okay, ready for the questions for that June 22nd, which is the Tuesday before the star party. So we're gonna kind of study up ahead of time so that when we get out there, assuming it's clear.
Assuming
I mean, the sour cherries were one thing, but the weather is
is another.
the weather is
another
another
battle.
thing, right? Okay. Melanie is going to put up for us to see in the next 2 weeks or another. Well, you leave up this one for a week and then put the new one up so
Mhm.
people can look at this. All righty, the circumpolar stars. And then another one where we can use the Big Dipper as both a clock, I'll talk to you later about it,
Okay.
and a calendar. So if you know what time of night it is, you look up at the Big Dipper, you know what season it is, or vice versa. If you know it's winter and you look up at 9 o'clock, you can tell, or no, if you look up at the Big Dipper, you know what time it is. Quite clever. Don't need a watch, don't need a smartphone, just look up if it's clear. All righty. Jordan, are they still interested and just can't make it today, or should I just give you the questions?
No, they're still interested.
Okay, then for Brock, what is the name of the pole star?
A pole star?
The pole, P-O-L-E, star. It has a name. What is it?
Okay.
Okay, now Megan and Melanie. Melanie is going to find out what the altitude of the pole star is here in New York. And
Repeat.
Megan is going to find the altitude of the pole star in San Diego?
Oh,
Yeah. Now, altitude, Jordan, means how high above the horizon is it, the northern horizon? I'll talk to, he's
Okay.
going to call me later. So when you call me later, we'll go over that, okay?
All right.
All righty. The Pipos are going to, I'll have to call them, go over how we can use the Big Dipper as a clock and a calendar. Jordan, Drew is to find out the 5 constellations that circle around the pole star. What are the 5 constellations that go round and around the pole star?
Okay.
Debbie, you still there?
I'm here.
You like asterisms. What is the asterism in the Great Bear constellation?
What is the asterism?
In the Great Bear.
Okay.
Remember when we talked about asterisms?
Mhm.
Sometimes they were part of a constellation. Well, this is part of the Great Bear, but what is it? Okay, I'm going to give this one to Rima. One of those constellations that Drew is going to find is in the shape of an M or a W, depending on the time of the night or the time of the year that you look for it. So is it at 10 o'clock in June? Is Cassiopeia, I gave you the name of one of those, Drew. Is it an M or is it a W as we look up and look at it? I have to go out and look at it. I'm not sure. I do know if I thought about it. Okay, that's going to be Rima's question. All righty, Mary Lou, you ready?
yeah.
We use the Big Dipper in many ways as a pointer. If you follow the handle of the dipper, what bright star in the sky does it lead you to?
Okay. Oh, I
Okay.
know that one.
Okay, she knows it already. Good. Laura didn't sign in, did she? She's running around. Okay, so I'll call Laura, and her question is going to be, part of the Big Dipper is those 2 double stars, Mizar and Alcor, and they have a famous history for a couple of reasons. So where do you find them in the Big Dipper, and what's their history? All righty, who am I going to stick? Melanie, do you have one yet? Yeah, you have a simple one. Who else am I forgetting? Oh, Sandy. Haha. Sandy's down in Florida, so we're going to stick her with this one. How did the pole star help Columbus discover America? You see,
Repeat that.
it never gets any credit. He gets all the credit, right? Well, if it wasn't for the pole star, he probably would never have found America.
Repeat that question.
Okay, how did the pole star help Columbus discover America? Okay, do we, what time is it?
It is 1:50.
Do I have 3 more minutes? Okay. So we're done with the topic, but something came up on the news that just like hearing the wind on Mars was like, oh, wow, really? Because usually scientific discoveries don't happen overnight. Often they take years of research, in some cases, centuries back in the day, before we figured out the Earth was not the center. It took centuries. I have talked about, did I bring the picture? Well, anyway, I have talked off and on, and I've written about the zodiacal light, which I've always wanted to see and have never succeeded. It's easier if you live further north, near the Arctic Circle. But once in a while, just like Northern Lights, you can see it, usually in spring and fall. around the time of the equinoxes. And it's usually in the twilight, either right after the sun goes down, maybe an hour later, or in the morning, an hour before the sun comes up. And what it is a faint glow of light in the sky, about as bright as the Milky Way, but a haze, and it's shaped like a pyramid, starting at the horizon where the sun was just set or going to rise. And then it goes up halfway to the sky into like a pyramid shape. And it's called the zodiacal light. And scientists thought that basically what it was, the space in the solar system is not a total vacuum. There's some very, very, very fine dust, let's call it rubble, junk, dust, very fine small particles still floating around out there. Just like in a room, if you shake your dust rag in the room and the sun is shining from the window, you can see all the little dust motes floating around. So scientists always thought it was basically from the whole solar system. And guess what? 10, 15 or so years ago, one of those spacecrafts, I wrote it down and now I forgot what it was, went out to Jupiter, maybe the Juno spacecraft. And it was, those spacecrafts have large sails on them that collect the sunlight that's getting fainter and fainter the further out they go, to energize all the computers on board so the thing keeps going and doing what it's supposed to do. And so they just, and then they take pictures. And then they finally, the pictures come back, and what do? They don't have time to sit down and analyze everything right away, right? Because so much information is coming in. So it's like the museum, the dinosaur bones get stored. And eventually someone's going to get around to looking at them. So 10, 15 years have gone by, and these photos are sitting in the drawer, and some young astronomer's assistant or whoever, I'm sorry if it was somebody famous, I forget. And he got around to looking and analyzing them. And guess what? These big sails, as they left Earth's orbit and went through Mars's orbit, that's where it all collected, this red dust. And now the new theory is, and they're pretty positive that this is it, all that, what did I call it? Yes, right. Now, did you write it down? What was I talking about that I never could see?
The
Zodiacal light is simply dust from Mars's red surface. And that's causing the light because those particles are right in that band.
Interesting.
I think it's interesting. So, and we will see, the next 10 years, maybe they'll smooth out the theory or prove more of it. But it seemed to me well, that's pretty amazing.
Yeah.
And that makes, it's like in biology, why they don't want you to cut down the Amazon rainforest. There's so much there that we know nothing about. And we're destroying species who could save our life someday because we don't even know it. And so there's so much knowledge out there that we don't have the time to analyze it and think about it. So anyway, so on that thought, does anybody have any questions before we close out what's turned out to be an hour? Nope. Nope. Jordan, you have anything?
I think Debbie has a question.
Oh, Debbie?
Yeah, this was way back in the beginning of the hour when you were talking about holding up your pinky.
Oh, yes.
What part of my pinky is going to block?
The width of it from side to side. The tip of your pinky from side to side is half a degree.
Okay. All right. So
And
it's the length finger to the end.
Pardon?
It's not the length of my pinky from my hand.
No. It's the width.
Oh, okay.
I think way back, here we go, day one of our sessions, the moon and your pinky held straight up. Can we do this here? You want to adjust it?
Oh, okay.
Okay, guys, take a look. This is your 3 fingers, your fist,
There's
your pinky.
Oh, got it.
So each one is a gauge to degrees. So if a star is 5 degrees from Sirius, is that your fist?
Yeah.
No,
Your 3 fingers.
3 fingers. And your fist is 10 degrees. So once again, at arm's length, held up to the sky, it just gives you a rough, as
Okay,
Laura would jokingly say, you're a rule of thumb.
got it.
Okay. Any other questions?
Wait,
I'll
what
be
was the
real-
question that I got again? I wrote down the other 3, but I missed what mine was.
Whoops. What was yours? What did I just do with the paper? For this time, Jordan? Hang on. Oh, maybe I tell you what, I'll give you the same one as Rima. All right, because she's busy training a new work study student. Cassiopeia, which is a circumpolar constellation, sometimes looks like the letter M and sometimes like the letter W. So right now in June at around 10 o'clock at night, and you look north, is Cassiopeia an M or a W? Got it?
Yeah, I got it. Okay.
All right. Now, how many of you have some sort of astronomy app on your phone that she does, that you can see the stars at night? There's several ways they do it. Sometimes you have to hold the phone up to the sky and it simply shows you what's there.
Mhm.
Sometimes you can press in the date and your latitude and it shows you what's there. Does anybody besides Melanie have one of these on their phone? Laura does, although we
So,
haven't
like, it's-
figured out how to work it.
Yeah.
Okay, well, if you have that, bring it with you to the star party on the 26th, because ahead of time, while it's getting dark, and we're waiting for, what do they call it? There's a word for that when you can actually see the stars, 3 different levels. You know, the brightest, the next, and the dimmest.
Yes.
We can look up what we're going to be seeing, and it always helps to have an idea of what we're looking for. Okay. Okay. Now this was recorded.
Yes, this was recorded.
So you can go back and re-listen if you want. And by the way, before we cancel off, in a month's time, I've assigned Jordan and his crew a rather elaborate experiment to do. And Melanie, if Megan takes a picture there,
Mhm.
she can transfer it to us, right? Okay, we'll
Yep,
figure
she can.
out how to do that. But in a month's time, unfortunately, we should have done it in 2 weeks. But in 4 weeks, we're going to talk about the summer solstice, which I think this year is on the 20th. So it'll be after the fact. But we'll be talking about the tilt of the Earth. And Jordan is going to be researching the tilt of Uranus. Jordan, you want to tell us what the tilt of Uranus is like?
It's at 90 degrees, so it's almost on its side.
Right, well, 88 degrees, I think. So it's
Oh,
like
yeah.
tipped almost sideways, which means it
Yeah.
rolls around its equator, around its orbit on its equator. Now, what the hell does that mean as far as their day, night, seasons, and whatnot? It's quite a different world. And so Jordan is researching that, and then his household is going to do an experiment, all 4 of them, and we're going to actually see. If you find a tennis ball, that'd be so much better than the orange, Jordan, okay?
I'll
Still there?
try to, yeah.
Okay, all right. Don't buy a whole bunch of tennis balls for this, but it would be much easier if you could use a tennis ball, or well, I suppose a ping pong ball, but that makes it kind of small. Okay, I guess that's it. We've run out the hour this time. So see you all in, don't forget, the library is going to try and get something on the webpage.
Yeah, I'll put a link to, it should be a NASA live stream for the
Annular eclipse.
Yep. And I'll put that on our website and probably our social media too.
Okay, so you don't have to go up to Greenland
You don't have to go to Greenland.
and sit in the clouds.
No.
All right, guys, have fun.
Bye.
Next week.